Welcome back to the deep dive. Today we are diving into probably one of the most heated debates you can have in a grocery store: organic food versus genetically modified organisms, or GMOs.
Yeah, this is a big one. And it's necessary because this isn't just about what's for dinner. It's become a moral, environmental, and frankly, a huge financial fight.
Billions of dollars.
Billions. And it's all based on claims about these labels. And a lot of those claims, they're often based more on marketing or even fear than what the science actually shows. Our mission today is to cut through that.
That's exactly right. And we're going to treat this whole thing like a really serious science fair project. We're taking all those popular claims, organic is healthier, GMOs are Frankenstein food,
All of them.
and we're going to test them against the actual evidence. We want to stick to what we're calling the eighth grader analogy rule today. Simple concepts, but a really deep understanding. No jargon.
And the central question we have to solve is this. Is organic food really that perfect chemical-free ideal? Or is modern tech, like GMOs, actually a safe and essential tool?
Or is it something in between? So before we get into the weeds, let's start with the big picture, the overall consensus. What does the vast majority of scientific research say when you just look at the food on the plate?
Well, the overwhelming evidence, and I mean mountains of it, suggests that both organic and conventional systems, they produce food that is similarly safe to eat, and for the most part, similarly nutritious.
Okay, hold on, because I think that right there is the single most important aha moment. If the consensus is that both are safe and nutritionally pretty much the same, then the choice isn't really about your personal health in that direct way. It's about something else entirely. It's about the trade-offs.
Exactly. It's all about the trade-offs and how we farm and the impact that have on the environment. And that's the stuff that gets lost when you're just standing in the produce aisle trying to pick an apple.
One system prioritizes restricting inputs, the other prioritizes efficiency and yield. And understanding those different costs is really the key.
That's the whole game.
Okay, let's unpack this. We'll start with section 1. What does organic even mean? When you see that USDA seal, you get this image, right? A small family farm, no chemicals, everything's natural.
Right, that romanticized idea. But what organic actually is a regulatory and marketing term.
So it's a rule book.
It's a rule book. That's the perfect analogy. It's a government-mandated rule book for farming. It tells the farmer exactly how they have to manage their land. If you follow the rules, you get the certification, you get to use the label.
So let me look inside that book. What are the core rules? What's restricted that makes it different from, say, your standard conventional farm?
The whole philosophy is built on restricting certain modern industrial inputs. So the stuff farmers put on the land.
Okay, let's list them out so you know what you're paying for with that premium.
The big ones are, number 1, synthetic fertilizers, especially that highly soluble synthetic nitrogen that's, the backbone of modern high-yield farming.
Right.
2, most synthetic pesticides and herbicides. 3, genetically modified organisms, GMOs, are completely banned. And 4, routine antibiotics and growth hormones for livestock are either banned or very heavily restricted.
Let's stick with that first point for a second. The synthetic nitrogen fertilizer, that's a huge deal. Why is that one so important to restrict in the organic rulebook?
Well, it's arguably the single most powerful invention in modern agriculture. It's a huge reason we can feed billions of people. But it has a big environmental cost.
The runoff.
The runoff.
Yeah.
The process to make it is very energy intensive, and when the excess washes off fields, it gets into rivers and oceans and causes massive water pollution. Things like those ocean dead zones.
So the organic farmer has to find a different way to get nitrogen into the soil.
Exactly. Instead of buying a bag of it, they have to rely on biological sources. So we're talking about compost, animal manure, or planting what are called green manure crops that literally pull nitrogen out of the air.
Which sounds a lot more labor intensive.
It is. And slower. And that directly contributes to the higher cost and, crucially, that yield gap we're going to talk about later.
Okay, so that brings us to the biggest myth of all, the one that really drives people to pay more. The belief that organic food is just flat out healthier. What does our science fair project say about that?
The answer here is remarkably clear. When you look at thousands of studies, big meta-analyses from all over the world, they find no consistent, meaningful difference in the main nutrients.
So things like vitamin C, calcium, iron.
All of it. Vitamins A, C, E, B vitamins, you name it. If I give a nutritionist two identical-looking apples, one organic and one not, they can't tell the difference from the main nutritional panel. It's just statistical noise.
It's the same variety of apple. The genetics are the same.
Exactly. The genetics of the plant and the soil it's grown in, those things matter way more than the organic versus conventional label.
But what about that nuance I always hear? The thing about antioxidants and other protective compounds?
Ah, yes, the secondary metabolites. So some studies do show that some organic produce might have slightly higher levels of things like antioxidants or polyphenols. But we have to be really, really careful not to oversell this,
Why? If it's higher, it's higher.
because the size of the difference is usually very small. And if you're already eating a healthy diet with lots of fruits and vegetables, that tiny bump is basically insignificant.
It's like a rounding error.
It's a rounding error. Let's use that running shoe analogy.
Yeah.
If you want to get healthy by running, the single most important thing you can do is just get out there and run.
Right.
Worrying if your organic carrot has 5% more polyphenols is like obsessing over the color of your running shoes when you haven't even started jogging yet. It's a distraction from the main thing, which is just eating plants, period.
I love that. So you're saying worrying about the label lets us feel good while avoiding the harder work of just eating enough vegetables in the first place.
It's a classic case of majoring in the minors.
Okay, let's tackle the next big one. This one causes a lot of anxiety. The idea that organic means pesticide-free.
The zero pesticide claim.
Yeah. So what's the reality for an organic farmer trying to stop bugs from eating their whole crop?
The reality is organic farmers absolutely do use pesticides. They have to. The rule book just says they have to use materials that are approved for organic use.
So mostly natural stuff.
Mostly natural compounds, plus a very short, very controlled list of approved synthetics. It's not no pesticides, it's no unapproved synthetic pesticides.
Can you give me an example of a common organic pesticide, something they'd actually spray?
A classic one is copper compounds. They're used as fungicides. Or another huge one is Bt, which is short for a bacterium, Bacillus thuringiensis. Organic farmers spray a protein from this common soil bacteria all over their plants to kill certain insects. It's 100% natural.
And that brings us right to that trap, the idea that natural always means safer.
This is where we have to be really critical thinkers. Just because something is natural doesn't mean it's benign. I mean, rattlesnake venom is natural.
Right, I wouldn't put that on my salad.
Exactly. And in farming, some of these older naturally derived materials can actually be more toxic or more persistent in the environment than some of the modern targeted synthetics.
So how does something like copper compare to a modern synthetic fungicide?
Well, copper compounds are what we'd call broad spectrum. They can harm a lot of different organisms, and they don't break down. They can build up in the soil over time and actually become toxic to the soil life itself.
Whereas a modern synthetic chemical might be designed to do its job and then just disappear.
Precisely. A lot of modern chemistry is focused on high efficiency and rapid breakdown. So it targets the pest, and then it's gone. Some organic farmers are kind of stuck using older, less efficient tools that can stick around longer.
But for the person eating the food, the real question is about the residue. What's left on the apple?
And that's the key takeaway. For both organic and conventional foods, the average pesticide residues that are found are consistently far, far below the safety limits set by agencies like the EPA. The actual health risk from those tiny residues in either system is considered extremely low.
So the biggest risk is still just not eating the apple at all.
Not eating the apple, that's the real danger.
Okay, so if synthetic pesticide residues aren't the main threat, what about other things? Let's talk about unseen contaminants that can affect any farm, including organic ones.
Right, because food safety is more than just synthetic chemicals. Organic food is very safe, just like conventional food. But we have to admit that when you remove one set of tools, you can sometimes increase other risks.
Like what? What kind of biological contaminants?
Well, the obvious ones are pathogens like E. coli or salmonella, which can come from using raw manure, which is a key organic fertilizer. But a more subtle issue that surveillance data points to is fungal toxins, mycotoxins.
Mycotoxins, what are they?
They're basically poisons produced by molds that can grow on crops, especially grains like corn and wheat. The most famous one is aflatoxin. It's a known carcinogen, it can cause liver cancer, it's completely natural, and it is incredibly dangerous.
And there's a surprising finding in some of the data when you compare organic and conventional grains here.
Yeah, some surveillance has actually found higher levels of certain mycotoxins in organic grains, especially corn, compared to their conventional counterparts.
Why would that be? Why would the organic crop be more vulnerable to a natural toxin?
It all comes back to pest management. Fungi, these molds, they love to attack a plant that's already stressed or damaged.
Ah, so if a bug chews a hole in a corn kernel,
That's the entry point. The insect damage creates a little wound where the mold spores can get in, germinate, and start pumping out mycotoxins.
and if the organic system restricts the most effective insecticides, you potentially get more insect damage, which opens the door for more fungal infection.
That's the chain of events. Conventional farming often uses tools, including GM traits, that specifically protect the plant from that initial insect damage. So it's a classic trade-off. You lower the risk of a synthetic residue, but you might, in some cases, increase the risk of a very harmful natural contaminant.
Let's shift from human health to the planet's health. This is where organic is often seen as the clear winner because it uses fewer industrial chemicals. So where are the clear environmental wins for organic?
The wins are definitely there. Organic farming uses less synthetic nitrogen fertilizer and fewer synthetic pesticides. So per field or per hectare, that's a great thing. It reduces local pollution, especially that nitrogen runoff we talked about.
It's better for the soil, right?
Generally, yes. Organic practices tend to build up healthier soil over time, which is better for biodiversity and holding on to water.
Okay, so healthier soil, less runoff per field. That's a clear benefit. Now, what's the giant counterweight on the other side of this environmental scale?
The counterweight is the yield gap problem. The big one. Because the organic rulebook restricts access to those powerful yield-boosting tools, organic farming almost always results in lower yields.
How much lower are we talking?
The sources show it's commonly a 20 to 40% lower yield for many of the big staple crops. You just get less food from the same amount of land, on average.
And that creates a massive environmental dilemma if we think about scaling this up to feed the whole world.
It's the core dilemma. To get the same amount of food we produce today, if every farm suddenly yielded 30% less.
You'd need 30% more farmland.
And where does that land come from? It has to come from somewhere. It means cutting down forests, draining wetlands, plowing up grasslands.
You're trading a reduction in chemical intensity for a huge increase in land use extensivity.
Exactly. And that additional land use, converting natural habitat to farmland, is often the single biggest environmental impact of agriculture. It can completely wipe out the benefits you gained on the original field.
So it forces this really tough question. Is it better to farm a small area very, very efficiently, using modern tools, or is it better to farm a much larger area less intensively?
There's no easy answer. And to be fair, some well-managed organic systems can close that yield gap significantly.
Right, I was going to ask about that. What about those studies showing that long-term organic farms, especially in a drought, can sometimes outperform conventional ones?
And that's a crucial point. A well-optimized organic farm that has spent decades building up soil health is incredibly resilient. That healthy soil holds water better. But when we look at the global average at mass market organic, that yield gap is a persistent major issue.
So let's talk about the money. Organic food costs more. If it's not really healthier and the environmental case is a complicated trade-off, what are we actually paying for?
For the most part, you're paying for production costs,
Mm-hmm.
primarily labor, and then the costs of certification, marketing, all of that.
You're paying for the inefficiency mandated by the rulebook.
That's a blunt way to put it, but yeah.
Yeah.
Weeding by hand instead of with an herbicide is just more expensive. You're paying for the process, not a superior product.
And if you're paying for a process, you have to trust the certification. How reliable is that?
Well, it's not perfect. Audits have found fraud. They found residue violations, especially with imported organic products from countries with less rigorous oversight.
So that gold star sticker isn't a 100% guarantee.
It means they're supposed to be following the rules. But in a massive global supply chain, ensuring that every single time, everywhere, is a huge challenge.
Okay, let's pivot. Time to unpack the other side. GMOs. If organic is about restricting things, GMOs are about adding a specific tool to solve a problem. This is where things get really emotional for people.
For sure. And we need to approach it with that same calm, science-first mindset. Let's just define what a GMO is, simply.
Right, the 8th grader rule. How do we explain genetic modification without getting lost in the biology?
I like the instruction manual analogy. Every living thing has a huge, complex instruction manual. It's DNA. It tells a plant how to grow, what to do. Genetic modification is when scientists find one very specific, useful instruction in one organism's manual.
Like what?
Like the instruction to make a protein that happens to be toxic to a specific pest, like the corn borer bug. They then carefully copy just that one instruction and paste it into the corn's instruction manual.
So it's very targeted, it's surgical, it's not like the old way of breeding plants, which was more like just smashing two instruction manuals together and hoping for the best.
Exactly. Traditional breeding is a game of chance. You get thousands of random, unwanted genetic changes along with the one you want. GM is precise. You know exactly what instruction you added. And the key thing to remember is that currently approved GM crops are considered by scientists to be just as safe to eat as their conventional cousins.
Okay, let's go straight to the safety question. The fear that these foods are somehow inherently dangerous. What's the consensus from the big global scientific bodies?
The consensus is incredibly strong. You look at the World Health Organization, the U.S. National Academies of Science, the European Food Safety Authority.
Hmm.
They all say the same thing. Approved GM foods on the market today are no riskier to your health than non-GM foods.
So if the consensus is that strong, why do we still hear about those studies that claim to find harm, the ones that get all the headlines?
Yeah. Because those few studies, which are often the foundation of the anti-GM movement, almost always get retracted or heavily discredited by the wider scientific community.
Why? What was wrong with them?
Usually they have fundamental design flaws. For instance, one very famous study used a type of rat that is already genetically prone to getting tumors no matter what you feed it. So, of course, a rat's got tumors.
Even the ones in the control group that weren't eating GMOs.
Exactly. Or they use tiny sample sizes or the wrong statistical methods to make random noise look like a significant finding. The whole system of peer review and regulatory science is designed to catch this kind of bad research.
Which brings up the other claim, that GMOs are rushed to market, that they're not tested enough because Big Ag controls the research.
That's just factually not true. It's actually the opposite. GM crops go through years and years of rigorous assessment before they're ever approved. It's far more scrutiny than a new conventionally bred crop gets.
Walk me through that. What does that testing actually involve?
It's a huge multi-year process. First, molecular characterization, where they check exactly where the new gene went. Then compositional analysis. This is the big one. They test the GM plant against its non-GM parent for every nutrient, protein, fat, allergen, everything.
To make sure nothing else changed.
To make sure nothing else changed, they look for what's called substantial equivalence. They also do environmental risk assessments and animal feeding studies. It's an incredibly thorough process.
And what about that idea that it's all industry-funded research? Is there any independent work?
Oh, absolutely. While the companies do the initial regulatory work, the scientific literature is full of hundreds of independent, peer-reviewed studies from universities and government labs all over the world, confirming the safety. The idea that it's only company research is a myth.
Okay, let's go back to the environment. The narrative here is that GMOs equal pesticide-drenched farming.
Which is a huge oversimplification. We have to think of GM traits as tools in a toolbox. They can be used in different ways with different outcomes. It's not one single system.
So what are the tools that have clear environmental benefits?
There are two big ones. The first is insect resistance. These are the beetscake crops, like beet corn or cotton.
The ones that make their own insecticide, that beet protein we talked about earlier.
Right, and that protein is very specific. It's toxic to the main pests, like the corn borer, but it's harmless to mammals, bees, and other beneficial insects.
So what's the environmental outcome of that?
It has led to a massive reduction in the need for farmers to spray broad-spectrum insecticides. Those are the sprays that kill everything. So by putting the resistance in the plant, you use far less spray, which is great for biodiversity and for the health of the farmers themselves.
Okay, that's a clear win. What's the second big tool?
The second one is herbicide tolerance. This is the one that gets a lot of criticism, but the environmental benefit is that it allows farmers to practice no-till farming.
So they don't have to plow the fields. Why is not plowing such a good thing?
Plowing, or tillage, is terrible for the soil. It releases huge amounts of carbon into the atmosphere, it destroys soil structure, and it leads to massive soil erosion.
All that topsoil washing away.
Exactly. By using no-till, which these crops enable, farmers keep the carbon in the ground, they prevent erosion, and they build much healthier soil over time. It's a massive climate and conservation benefit.
But there is a downside, the super weeds.
There is. And that's the big caveat. Over-relying on a single herbicide has, predictably, led to the evolution of herbicide-resistant weeds. But, and this is important, that's an agronomic management problem. It's about how the tool is used, not a flaw in the technology itself. Evolution will always find a way if you do the same thing over and over.
Let's talk about the final fear, corporate control. The idea that GMOs only exist to let huge corporations control the world's seed supply.
It's a valid concern, but it needs context. It's true that many GMCs are patented and farmers can't save them, but that whole system of patents and contracts applies to lots of modern seeds, including many non-GM hybrids.
So the business model of not saving seeds isn't unique to GMOs, it's part of the modern commercial seed industry in general.
Correct. The business structure is the same, but more importantly, the technology of genetic engineering itself is not tied to that one economic model.
Meaning it can be used for other things, not just for profit.
Exactly. There are tons of public sector and nonprofit projects using GM technology for humanitarian goals.
Give me an example.
Public research labs are developing things like drought-resistant cassava for smallholder farmers in Africa, or disease-resistant bananas. These are crops that big companies might never develop because there's no huge profit in it. It shows the technology itself is a neutral tool that can be used for public good.
Okay, so let's zoom out to the biggest picture of all. Food security, hunger, and actually saving lives.
This is where we have to move beyond our own grocery store choices and look at the global scale.
We talked about the yield gap. How important is that difference in productivity when you're trying to feed billions?
It's hugely important. Conventional high-input agriculture, which often includes GM crops, simply produces more food per acre. The meta-analyses show that organic yields are, on average, somewhere between 5 and 34% lower.
But we have to be careful not to give all the credit for high yields just to the GMO trade.
Oh, absolutely not. High yield is a package deal. It's the seeds, yes, but it's also the fertilizer, the irrigation, the machinery. GMOs are one part of that system, especially by preventing crop losses, but they're not the whole story.
So this is where the conversation has to get very real. We've said safety is equal, but you're saying there's an area where GM tech has a unique, quantifiable benefit that goes beyond just calories.
Yes. This is where the debate needs to get very serious. We're talking about biofortification, using genetic modification to pack vital nutrients into staple crops.
And the number one example here is golden rice.
Golden rice. It's engineered to produce beta-carotene, which our bodies turn into vitamin A. It's designed specifically for regions where rice is all people have to eat, and vitamin A deficiency is a massive, massive problem.
How big of a problem is it? You give us the numbers.
The numbers are just devastating. According to the World Health Organization, vitamin A deficiency is the leading cause of preventable childhood blindness. It blinds between 250,000 and 500,000 kids every single year.
Every year.
And the most tragic part is that half of those children die within a year of going blind because their immune systems are so compromised.
My God. So this isn't about, a slightly better diet. This is life and death.
This is life and death. And the estimates, based on that data, suggest that if golden rice could reach these populations, it could prevent somewhere between 125,000 and 250,000 deaths every single year.
250,000 deaths averted. It just changes the entire frame of the conversation. So why isn't it everywhere?
The science has been ready for years. The barriers have been almost entirely political and regulatory, often driven by fierce opposition from anti-GM activist groups.
And golden rice isn't the only example of this, right?
Not at all. Orange flesh sweet potatoes, boosted with vitamin A, have had huge success in trials in Africa, dramatically improving the nutrition of young children. The technology works.
And you mentioned it can also reduce those natural toxins, the mycotoxins.
Right. By preventing insect damage in corn, some GM varieties reduce those cancer-causing mycotoxins by nearly 30%. So the benefits are layered.
Yeah.
More food, more nutritious food, and safer food by reducing natural contaminants.
This brings us to a really tricky claim I hear from both sides. You'll hear someone say, GMOs feed X million people, and then someone else says, organic can feed the world. Can we actually calculate any of that?
No, and this is a crucial point. There's no reliable scientific way to calculate that number. Any claim like that is pure speculation.
Why not? It seems like it should be simple math.
Because global hunger is not a production problem. We have to use the water in the bucket analogy here.
Okay.
The world already produces enough calories to feed about 10 billion people. The bucket of water is full.
So if the bucket is full, why are people thirsty? Why are hundreds of millions of people starving?
Because hunger today is caused by poverty, conflict, lack of infrastructure, and inequality. The bucket is full, but people have broken pipes. Or they're cut off from the tap because of war or corruption.
So even if a GM crop boosts U.S. corn yields by 10%, there's no guarantee that food ever reaches a starving family in a conflict zone.
Exactly. The food system is too complex. It gets lost in trade, in storage, in local politics. The claim is meaningless.
And the same logic applies to the claim that organic alone can feed the world.
It does. That claim completely ignores the massive land use expansion that would be required because of the yield gap. It would be an ecological catastrophe. Both of those extreme claims are just propaganda. The reality is about logistics and politics, not just production methods.
Okay, let's bring all this back to you, the listener, trying to make a smart choice. Let's synthesize this.
I think the key insight is that neither system is a perfect solution. They are both toolkits with different trade-offs. With organic, you're choosing fewer synthetic inputs, but you're accepting lower average yields and more pressure on land. With conventional and GM, you get higher yields and land efficiency, but you accept the use of modern synthetic inputs.
So what's the most important choice for your own personal health?
The most important choice is just to eat more plants. It's that simple. Eat more fruits, vegetables, and whole grains. Worry far, far less about the label and far more about the sheer quantity of plants on your plate.
And understand what that label you're paying for actually means. It's a process, a set of farming rules. It's not a guarantee of better nutrition or safety because both systems are safe.
Right, and for global impact, we have to look past the labels at what specific technologies can do. And GM biofortification has proven it can prevent blindness and death in a way nothing else has.
It really shifts the question from, are GMOs safe, which the science says they are, to what problems can this tool solve that other methods can't?
Exactly. It can solve specific acute nutritional crises, even if it can't solve the bigger political problems that cause hunger.
That is a huge amount to take in, but the conclusion feels surprisingly balanced. It's not good versus evil. It's a choice between systems of trade-offs.
And it's about remembering that all of these tools, whether it's an organic method for building soil or a genetic method for saving a child's eyesight, should be valued for what they can actually do, not just the emotional label we attach to them.
Which brings us to our final thought.
We know with scientific certainty that a tool like golden rice can quantifiably prevent blindness and death. We also know that global hunger is primarily a problem of logistics, poverty, and politics, not a lack of calories.
So considering that massive disconnect is our intense focus on labels in the grocery store, on arguing about yield differences, is it distracting us from the real, harder challenges of distribution, equity, and political stability? Are we arguing about the quality of the water while hundreds of thousands of people die because their taps are turned off?
That's the question we want to leave you with.
Thanks for coming along on this deep dive with us. Remember to follow us on your favorite podcast platform and see you on the next dive.